All right, so one thing that we might want to do then is compare our results for our metaregressions in our subgroups. Let's do that now. Okay, so let's look at the community sample then. All right, so let's do a subgroups analysis on the community sample. Okay, we can see we have an estimate of 0.04, all right, based on 15 effect sizes and a tau squared of 0.019. Okay. Let's now do it as okay. As meta-regression, it's slightly smaller. But in neither case is it significant, so it's no big deal. But let's do it for workplace. Okay, so you can see it's not significant in the subgroups, but workplace is significant in the meta-regression. All right, so here's the meta-regression here for workplace 0.24. It's 0.22. And you can see the standard error here is lower, all right? So it's getting to use all that extra information from the other studies. And the last one we'll do is high school. Okay, 0.106, 0.106, all right. So it's very similar. And in both cases, it's significant. So the only one where we get different results is this workplace sample, okay? If we run the subgroups analysis here, you can see there's a huge amount of variability, much more than even the average, right? If we remember back to our first analysis we ran way back when, which was just a meta-analysis of this data, there was something about 70% heterogeneity. You can see that the workplace sample actually has even more, okay? So if we use that larger estimate that is particularly related to the workplace sample, it's not significant. If we do our meta-regression, which uses the overall value of heterogeneity, we can see actually workplace is significant, right? So you may get different results for subgroups and a meta-regression. It can sometimes get you tongue-tied in a paper. What do you say if you get different results? I'm going to put a reference into the notes below that might help you discuss the two approaches. And when the pooled estimate of the tau squared, right, so the average for the whole set of data is better to use, and when it's not. So hopefully that can help you settle that debate for yourself, but there's no real right answer per se.